Yeah, good morning, students.
Good morning, sir.
Good morning, sir.
Is screen is visible?
Yes, sir.
Yes, sir.
Okay. I will again start with the Rolle's theorem. Okay. Firstly, see. Rolle's theorem. Statement is, if f of x is a function, such that first condition, f of x is continuous in closed interval a comma b. Second condition, f of x is derivable in open interval a comma b. And third condition, f of a equal to f of b, then f of a equal to f of b, then there exists a point C. Belongs to open interval a comma b, means not equal to a, not equal to b, such that f dash c equals to 0. Statement: it is continuous in closed interval and derivable in open interval, and the value of the function at the endpoints a and b is equal. Okay, and then there exists a point C belongs to open AB such that f dash c equals to 0. And what is geometric representation of this Rolle's theorem? Geometric representation. The first point, f of x is continuous. In closed AB. Means what? The curve y equal to f of x is defined. At every point. Defined means what? Let me write. Defined means exist finitely and uniquely. That means left limit value, right limit value, both are same at that point, at every point, is defined at every point of closed interval a comma b. Means continuous means, now if I consider maybe here also a and b, the curve must be continuous. Like this. It is a continuous case. And second condition, f of x is derivable. In open AB. Derivable in open AB means the curve f of x, y equal to f of x has tangent at every intermediate point. Means what? A, B is there. This is some curve. Okay. At every point there must be a tangent, like this. At every point there is a tangent. Derivability means the curve possesses a tangent at a particular point. And the third one. And what is derivative condition? You know, left derivative, right derivative, both are equal. And third condition, f of a equal to f of b. Third condition, f of a equal to f of b means the curve has same value at the endpoints. This means the curve y equal to f of x has same value at x equal to a and x equal to b. Meaning is what? Now the point is, if it is a and this is b, This is the point A. What is this point A comma f of A? And this point and this point both must be at same level, B comma f of B. Now you draw the curve like choice is yours, whatever the curve, both must be at same level, this one and this one, f of A equal to f of B. Then what is the condition? There exists C belongs to open AB such that f dash C equals to 0. That is there is a point, there exists a point C, belongs to open AB at which the tangent f dash generally y equal to f of x is curve, then y dash is nothing but f dash x is called what? Slope of the tangent, slope of the tangent to the curve. And when slope is equal to 0 means what? The corresponding tangent is parallel to x-axis, at which tangent is parallel to x-axis. Tangent is parallel to x-axis. Now the figure is, if I consider A and a B, and this is point A, and at the same level this is point B, you draw some curve, no problem, like this. This is the curve, and the point C may be here. The point C may be here. At this point, the tangent is parallel to x-axis. Maybe point C may be here also. The point C may be here also. Okay, then there is a tangent parallel to x-axis. This is geometric interpretation of Rolle's theorem. Geometric interpretation of Rolle's theorem. Another one, parametric interpretation. Parametric interpretation or parametric form of Rolle's theorem. Parametric form of Rolle's theorem. What is this parametric form of Rolle's theorem? If f of x is a function, f of x is a function such that, first condition, f of x is continuous. F of x is continuous in closed A comma previously B. In place of B, the value is taken as A plus H, means neighboring point. For A, neighboring point is A plus H. And second one, f of x is derivable. F of x is derivable in open interval A comma A plus H. In place of B, A plus H is there. And third condition, f of A equal to f of A plus H. F of A equal to f of A plus H. Then there exists C belongs to open AB. Now here there exists theta belongs to open 0 comma 1 such that f dash of A plus theta H is equals to 0. See the difference. What is this? Theta belongs to 0 1 such that in place of f dash is C. In place of C, what is the value now? A plus theta H. F dash A plus theta H equal to 0. Hint is what? In Rolle's theorem, we have what is C belongs to what? Open A comma B, right? That means what? C lies between A and B. C lies between A and B. And what is the substitution of C here? A plus theta H. Let C equal to A plus theta H. And what is another substitution? B equal to A plus H. Then this is A less than A plus theta H less than A plus H. This implies what? A is getting cancelled, or subtracting A, this theta H less than H. Now H gets cancelled. This is 0 less than theta less than 1. That means what? Theta belongs to what? Open 0 comma 1. See, C belongs to A comma B is now reduces to theta belongs to 0 comma 1. So here, after satisfying these three conditions, there exists theta belongs to what is the interval? Not A comma A plus H, 0 comma 1, such that f dash A plus theta H equals to 0. This is Rolle's theorem. And one more point here. Note. What is the note? Coming to continuity and differentiability. The points are every polynomial is, right? Polynomial means, you know, every polynomial is Polynomial means what? A naught x power n plus a1 x power n minus 1 and so on an. This is the polynomial f of x equal to. Every polynomial is continuous everywhere. Every polynomial is continuous and differentiable. Every polynomial is continuous and differentiable everywhere. Everywhere. That means for all x belongs to R. For all x belongs to R. This is the first point. And the second one, what is sine function? Sine function, cosine function, right? E power x function, okay, are continuous everywhere. Are continuous everywhere. These are standard forms. And you know what is the logarithm? Log x is continuous on positive real numbers. Log x is continuous on positive real numbers, like that. Some standard functions are there which are always continuous and differentiable functions. These are also continuous everywhere and differentiable. Continuous everywhere and differentiable. And the next one is Lagrange's mean value theorem. Lagrange's mean value theorem. Now, statement is, if f of x is a function, if f of x is a function such that first point, f of x is continuous. F of x is continuous in closed interval AB and derivable in open interval. Derivable means differentiable in open interval AB. Only two conditions. Third condition is not there. F of A equal to f of B. Okay. That means f of A not equal to f of B. That must be true for Lagrange's mean value theorem. Then there exists C belongs to open AB such that C belongs to open AB such that f dash C equals to f of B minus f of A whole by B minus A. F dash C equal to f of B minus f of A by B minus A. And geometrically, what is geometrical explanation? Geometrically, first one as usual, f of x is continuous. F of x is continuous means the curve y equal to f of x. The curve y equal to f of x is defined everywhere. Is defined at every point of the interval AB. Okay. Second one, f of x is derivable. F of x is derivable means what? The curve y equal to f of x. The curve y equal to f of x has tangent at every intermediate point. At every intermediate point. At every intermediate point. Then what is the conclusion? Then there exists C belongs to open AB such that f dash C equal to fb minus fa by b minus a. That is now let me write first. That is the tangent. F dash C means what? Slope of the tangent at point C. The tangent at C is parallel to the line segment or curve joining the points. What are the points? A comma f of b and b comma f of b. B comma f of b. Now graphically see first one. Let me consider A here and B here. Let me draw one simple graph. This is A point and this is B. Need not be equal. So let me consider, okay, take this point B here. This is B. Okay, A and B curve is continuous and differentiable everywhere. Then there is a point C. Let me take point C. Okay, what is the line segment joining A and B? This is the line segment joining A and B. This is the line segment joining A and B. and there is a tangent at point, there is a point C. Let me consider C, this point C, where the tangent is parallel to this line segment AB. Tangent is parallel to line segment AB. What is the meaning? Slope of AB. Slope of the line AB is what? Clearly this is point A comma f of A, and this is the point B comma f of B. B comma f of B. So what is the slope? FB minus FA by B minus A, right? And the f dash C means what? Slope of the curve, slope of the curve at C. Both slopes are equal. This is equal to this one, means this tangent is parallel to the line segment joining A and B. This is geometric interpretation of Lagrange's mean value theorem. Mean is nothing but slope. Mean is nothing but slope. That is why it is called Lagrange's mean value theorem. And one more point. After this, let me write parametric form. Same logic, same expressions. Parametric form of Lagrange's mean value theorem. First condition, if f of x is continuous, enclosed A comma, what is this? A plus h. F of x is derivable in open interval A plus h. That's it. In place of B, A plus h. Okay. Then there exists theta. Parametric form means not C. Theta belongs to 0 comma 1 such that what is the thing here? Such that f dash C, in place of C, what is the value? A plus theta h. Don't forget this. F dash of A plus theta h equal to f of B minus f of A by B minus A, you will get h. B minus A plus h minus A gets cancelled, and by h. This is parametric form of Lagrange's mean value theorem. And one more point. What is this? This is a note. Take a note. Since in LMT, in Lagrange's mean value theorem, what we have, f dash C equal to f of B minus f of A whole by B minus A. We can write from this expression, we can write, what is this? FB minus FA by B minus A lies between two values. What is the first one? Minimum of the function, minimum of f dash x, and this one is maximum of f dash x. Inequality. This inequality is true because of this Lagrange's mean value theorem. This C may be any point. That's why I'm writing this x. C may be anywhere at which tangent is parallel to the curve AB. That means minimum value, this FB minus FA value lies between minimum and maximum of f dash x. Minimum and maximum of f dash x. This is Lagrange's mean value theorem. And parametric form is over. Right. Another one. Cauchy mean value theorem. Cauchy's mean value theorem. See the statement. Cauchy's mean value theorem statement. First point is, and in Lagrange's, one more point. In Lagrange's mean value theorem, if f of A, in Lagrange's mean value theorem, if f of A equal to f of B, then f dash equal to 0. So let me write, if in LMT f of A equal to f of B, then f dash C equals to 0. That is, LMT tends to Rolle's theorem. LMT tends to Rolle's theorem when f of A equals to f of B. Okay, this is one observation in LMT. And coming to Cauchy mean value theorem, if f of x and g of x, two functions here, not single function, two functions. If f of x and g of x are the functions such that, first point, f of x, g of x are continuous. f of x and g of x are continuous in closed interval AB. Second condition, f of x, g of x are derivable in open interval AB. Derivable in open interval AB. And the third condition is there. What is that? G dash x never 0. G dash x never 0 for all x belongs to open AB. For all x belongs to open AB. G dash x. No condition on, there is no condition for f dash x, only g dash x. Then there exists a c belongs to open AB such that what is the kind of result is f dash c by g dash c equal to f of b minus f of a by g of b minus g of a. F dash c by g dash c equal to f of b minus f of a by g of b minus g of a. Okay, now one note. If why, see this third condition, g dash x not equal to 0 for all x belongs to AB. Where is c? C belongs to open AB. That is why in denominator, what is the term? G dash is there. G dash, therefore this denominator should not be 0. That is why this third condition is included in Cauchy mean value theorem. And what is this? Next one, if g of x equal to x, if g of x equal to x, then what is g dash x? 1. Then CMT implies, what is this become C? F dash C by, what is G dash C becomes 1 equal to FB minus FA by G of x equal to x. Therefore, G of B is B. G of A is A. What is this is? Which is Lagrange's mean value theorem. Which is Lagrange's mean value theorem. Therefore, what is the conclusion? Therefore, when G of x equal to x, then Cauchy mean value theorem tends to Lagrange's mean value theorem. Lagrange's mean value theorem. That's the first point. And another one, parametric form. Parametric form. What is the first condition? F of x, g of x are continuous in open closed a comma a plus h. Second one, f of x, g of x are derivable in open a comma a plus h. And third condition, g dash x not equals to 0 in open a comma a plus h. These three conditions. Then there exist C, not C. Parametric form means theta. Theta belongs to what interval? 0, 1, such that f dash of C in place of C, what is the value? A plus theta h. G dash of A plus theta h is equal to f of A plus h minus f of A whole by g of A plus h minus g of A. This is Cauchy mean value theorem parametric form. And for your this one, geometrically or geometric explanation of CMT, geometric exploitation of CMT. Okay, try this one tomorrow. Tomorrow you tell, in the next class you tell what is the geometric explanation of CMT. Okay, this is assignment for geometric for Nagakshita. You are there?
Yes, sir.
Hello?
Yes, sir.
In the next class you explain what is geometric. In the next class you explain what is geometric explanation of Cauchy mean value theorem.
Okay,
Okay.
sir. Okay, sir.
Okay. Now, see the problems. One by one problems based on Rolle's theorem and Lagrange's mean value theorem, and next Cauchy mean value theorem. First one, verify. I think you did in intermediate this problem, maybe. Verify Rolle's theorem. Someone called Rolle's theorem or some other called Rolle's theorem. verify Role's theorem for f of x equal to x minus a whole to the power of m, x minus b whole to the power of n, where m, n are positive integers, enclosed a comma b, Solution. What is this function? F of x equal to x minus a whole power m into x minus b whole power n. X minus a whole power n into x minus b whole power n. See, if I expand this function, which is, if I expand this function, in this first term, x power m is there. In the second one, x power n is there. So it is clearly a polynomial, which is a polynomial of what degree? Degree m plus n. Hence, every polynomial is continuous and differentiable. Hence, it is continuous. Hence, it is continuous and differentiable. Differentiable everywhere. Continuous and differentiable everywhere. So, first two conditions are satisfied. Therefore, f of x is continuous in what is interval? Closed AB, and f of x is derivable in open AB. And see, you may have one doubt, why it is not derivable in closed A comma B. It is sufficient in open A comma B. If it is derivable in closed AB, don't bother. Yes, maybe okay, but what is the conclusion? There exists C belongs to what interval? Okay, open AB, and at C, what is this one? Derivative is there. So derivative must be there in open interval. That is enough for me. That is sufficient for me. Therefore, in the Role's theorem, derivability condition is defined in open AB. Derivability condition defined in open AB. And these two conditions are satisfied. Now, what is f of a? Clearly, what is f of a? A minus a, that is 0. And what is f of b also? If I put in play in this function, x equal to a and x equal to b, both become 0. F of a equal to f of b equal to 0. Clearly, f of a equal to f of b. Since the conditions of Rolle's theorem satisfied, conditions of Rolle's theorem satisfied, when satisfied, what exists? There exists C belongs to open AB such that f dash C equals to 0. C belongs to open AB such that f dash C equals to 0. So first let me find f dash C. What is this? X minus a whole power m, x minus b whole power n. This implies what is f dash x? UV method. M into x minus a whole power m minus 1 into x minus b whole power n plus x minus a whole power m into n into x minus b whole power n minus 1. Okay. Now this equal to f dash x equal to, what is the common? One can take x minus a whole power m minus 1 common, x minus b whole power n minus 1 common. So this is m into you will get x minus b, and here n into you will get x minus a. Right? Now f dash c equals to 0. F dash c equals to 0 implies in place of x, c. In place of x, c. So c minus a whole power m minus 1, c minus b whole power n minus 1, m into c minus b plus n into c minus a equal to 0. So how many chances we have? A into b into c equal to 0. So either a equal to 0, b equal to 0, or c equal to 0. So c minus a whole power m minus 1 0, or c minus b whole power n minus 1 0, or this one m into c minus b plus n into c minus a equal to 0. From this, what is this? Is c equal to a, which does not belongs to open AB, or c equal to b does not belongs to open AB, right? Open interval a comma b. Or what is this one now? This is I need c value. So c common, m plus n will be there, and remaining terms onto that side. That is mb plus na. So c is nothing but mb plus na by m plus n. It is the point which lies between a and b. This is the value of c. This is the value of c. Therefore, Rolle's theorem is verified. Rolle's theorem is verified. This is one problem. Okay. Next one, second one. You take exercise. Where is the exercise? Right. Verify Rolle's theorem. RT stands for Rolle's theorem. Verify Rolle's theorem for y equal to e to the power of x into sin x minus cos x in the interval pi by 4 to 5 pi by 4. Pi by 4 to 5 pi by 4. Solution. What is this? E power x comma sin x and sin x. These are the functions involved in f of x, right? So e power x, sin x and cos x are continuous and differentiable, derivable. Continuous and derivable everywhere. Continuous and derivable everywhere. Okay. Therefore, f of x equal to e power x into sin x minus cos x is continuous in closed pi by 4 to 5 pi by 4 and derivable in open pi by 4 to 5 pi by 4. This the first and second conditions are satisfied. Now f of a value is what? Pi by 4. A value is what? Pi by 4. So e power pi by 4 sin pi by 4 cos pi by 4. So sin pi by 4 equal to cos pi by 4, 0. F of b 5 pi by 4. 5 pi by 4. So e power 5 pi by 4 sin 5 pi by 4 minus cos 5 pi by 4. Is it 0? Yes?
Yes, sir.
45 into 4, 225. 225. Yeah, 0. Yeah. Since conditions of Rolle's theorem satisfied, there exists C belongs to what is the interval? Open 5 pi by 4 to 5 pi by 4 such that f dash C equals to 0. And what is f dash C? And here f dash x, UV method. First e power x derivative e power x sin x minus cos x as it is. Now e power x constant, sin x derivative this, and cosine x derivative minus. Now f dash c equals to 0 implies e power c is common, sin c minus cos c plus sin c equal to 0. So these two gets cancelled. This implies e power c 2 sin c equals to 0. That implies sin c equals to 0, since exponential function never 0. Exponential function e power c not equal to 0. Sin c equal to 0 means what? C equal to, yes, c equal to 0, pi plus or minus pi plus or minus 2 pi and so on, right? And what is our interval? 45 to 225. So which value? Plus pi is there. This implies c equal to pi belongs to what interval? Pi by 4 to 5 pi by 4. Hence, Rolle's theorem is verified. Hence, Rolle's theorem is verified. This is one problem. And the next one, same. Verify Rolle's theorem for function is f of x equal to x into x plus 3 into e power minus 1 by 2x in what interval? Minus 3 comma 0. In minus 3 comma 0. And yeah, in Rolle's theorem many problems are there. Let me check. Okay. Solution. Firstly, x into x plus 3, that is nothing but polynomial, is continuous everywhere. Is continuous everywhere. Second degree polynomial. And e to the power of minus 1 by 2x, exponential function, is an exponential function continuous everywhere. Continuous everywhere. Therefore, f of x equal to x into x plus 3 e power minus 1 by 2x is continuous everywhere. Continuous everywhere, right? In exponential function, even if you put x equal to 0, e power minus infinity, value is 0. Okay. Now, coming to differentiability. F of x equal to what? X square plus 3x into e to the power of minus 1 by 2x. E to the power of minus 1 by 2x. Now, what is the differentiability? 2x, yeah, right there. What is f dash x if you calculate this? 2x plus 3 into e to the power of minus 1 by 2x plus x square plus 3x into what is e to the power of f of x derivative? E to the power of f of x into f dash x. F dash x means what? 1 by x derivative is what? 1 by x square. So 1 by 2x square you will get. Right? This is f of x. 1 by x derivative minus 1 by x square. So 1 by 2x square. Now what is the interval is given? Minus 3 to 0. Open interval. What is the interval? This is 0 and this is minus 3. This is the interval, minus 3 to 0. Open interval, not closed. So 0 is not included. F dash x is defined at every point. Is it correct? Any correction? C. At every point of what the interval? Minus 3 to 0. This derivative not exist only at x equal to 0. X equal to 0. But x equal to 0 is not included here. So it is differentiable. Okay. This implies f of x is derivable. F of x is derivable in open 3-0. Now, f of a. F of a means what? F of minus 3. So 0. F of b. What is f of b? B value 0. X into is there, so 0. This implies f of a equal to f of b. Therefore, by Rolex theorem, therefore, by Rolle's theorem, there exists C belongs to open minus 3-0 such that f dash c equals to 0. Already we calculated f dash c here. This one, let me write this is f dash c means 2c plus 3 e to the power of minus 1 by 2c plus x square plus 3x e to the power of minus 1 by c square plus 3c e power minus 1 by 2c square equal to 0. Okay, and what is the common here? E to the power of minus 1 by 2c is common. So remaining part 2c plus 3 plus c square plus 3c, right, by 2c square equal to 0. Just simplify this. E power minus 1 by 2c, never 0. At is when c equal to 0. C equal to 0 is not there. Therefore, it is never 0. So this bracket function is equal to 0. How to solve this? 1c gets cancelled. 2c plus 3 plus take c common. Yeah, c common. C plus 3 by 2c equal to 0. Right? This equal to, now take LCM. 4c square plus 6c plus c plus 3 equal to 0. This implies 4c square plus 7c plus 3 equal to 0. This is 12 and 3. Yeah, correct. Factorization. 4c plus 3c plus 3 equal to 0. 4c common, c plus 1. 3 common, c plus 1. So c plus 1 into 4c plus 3 equals to 0. So what are the values of c? C equal to -1 or c equal to -3 by 4. And what is our interval? -3 comma 0. So this is -3 and this is 0. -1 will be there. -1 will be there and -3 by 4 also there, right? Therefore, both are belongs to this one. So Rolle's theorem is verified. Both belongs to what? -3 comma 0. Rolle's theorem is verified. And there are some complicated problems in Rolle's theorem. Let me check. Tell us no. Where is that? It is not there. Yeah. Prove that between any two real roots of e power x into sine x equal to 1, there exists at least one root of e power x into cos x plus 1 equal to 0. There exists at least one root of e power x into cos x plus 1 equal to 0. This is one problem. See, solution. I will first take in a wrong way. That means, but it looks like it is correct, but it is wrong one. See how. First observation. First, let me understand the question. Let us understand the question. Prove that between any two real roots of what equation? E power x into sine x equal to 1. This is our given equation, and it has two real roots. And between those two real roots, there exists one root of another equation. So what is the given function here? E power x into sine x equal to 1. So first we have to assume function. What is f of x? What is f of x means here, obviously one will take, what is f of x? Obviously one will take f of x as what? E power x sin x minus 1. Then what is f dash x here? What is f dash x? This is UV method, e power x sin x plus e power x cos x will be there. And obviously this function is continuous everywhere and differentiable everywhere. And what is assumption here? Between any two real roots, let a comma b be the two real roots of f of x equal to 0. This is f of x equal to 0, you will get here equal to 0 if I take 1 here. So what is this? So f of a equal to what? F of b, because both are roots of f of x equal to 0. Since all the conditions, continuity satisfied, differentiability satisfied, and third condition also satisfied, therefore there exists c belongs to what? Open interval AB. What is c? It is another root of what? I have to get this equation now. Between these two real roots, there is a root c belongs to open AB such that what I am getting, f dash c equals to 0. What is f dash c? F dash c, f dash x is here. So f dash c means e power c sin c plus e power c cos c equal to what? 0. Equal to what? 0. But what I have to get clearly, e power, I have to get finally what? Say logic is I have to get e power c cos c plus 1 equal to 0. I have to get. Then from this I can write c is the root of what equation? E power x cos x plus 1 equal to 0. Okay, this is what I have to prove. So I have to get this one. I have to get this expression. E power c cos c is there, but plus 1 I have to get. Is this value is 1? E power c sin c value is 1. Anybody? E power c sin c value is 1. What I have? E power x sin x value is 1. E power x into sin x value is 1. And what is a? What are a comma b are the roots? That means e power a sin a value 1, e power b sin b value 1. But I don't know e power c sin c value whether it is 1 or not. So I cannot conclude this value as 1. So if I proceed in this manner, you will get a confusion here. Okay, so this method is wrong. So this procedure is wrong. Why this is wrong? By selecting the function, it is giving wrong answer. By selecting the function, it is given wrong answer. Now I am taking correct way. Correct way is what? Here, what is the function is given as e power x sin x equal to 1. Then you write, take e power x that side, e power this side, e power minus x sin x. Now assume the function, let the function f of x as e power x minus sin x equal to 0. Equal to 0. Right? Clearly, this exponential sign, both are continuous and differentiable. Clearly, f of x is continuous and derivable. Derivable in everywhere. Derivable everywhere. First point is over. Now let a comma b be the two real roots. Be the two real roots of f of x equal to 0. A comma b be the two real roots of f of x equal to 0. That means real f of a equal to 0 and what f of b also 0. So third condition is also satisfied. Therefore, by Rolle's theorem, there exists C belongs to open A B, right? Such that f dash C equals to what? 0. What is f dash C? Let us calculate. F dash C equals 0. F dash x equal to, okay? Let me write what is f of x. What is f of x? F of x equal to what? E power minus x minus sin x. This implies f dash x is what? Minus e power minus x minus cos x. Okay, so f dash c equals to 0 implies what? Minus e power minus c minus cos c equal to 0. Done? Okay, that implies you take like this. What is this? Yeah, e power minus c plus cos c equals to 0. Is it correct? Right. That implies cos c equal to what? Minus e power minus c. Cos c equal to what? Minus e power minus c. Take e power minus c this side. So e power c cos c equal to what? Minus 1. Okay, that implies e power c cos c plus 1 equal to 0. What is the meaning of this? This implies c is the root of what equation? E power x cos x plus 1 equal to 0, where c lies between the roots a and b, right? Now what is our answer? Question is what? For the given function, prove that between any two real roots a b there exists a root c of what equation? E power x into cos x plus 1 equal to 0 equation. right? Okay, this is one problem. These are the problems based on Rolle's theorem. Let me give some assignment problems. This is over. Yeah, right now. Take just 2 or 3 problems. I will give one. Verify Rolle's theorem for f of x equal to log of x square plus ab by x into a plus b, x into a plus b in OB. AB are positive real numbers. AB are positive real numbers. One problem. Another one, same, verify Rolle's theorem for f of x equal to x plus 2 whole cube, x minus 3 whole power minus 4 in interval minus 2 comma 3. Interval minus 2 comma 3. Another one, f of x equal to sin x over e power x in interval 0 to pi. In interval 0 to pi. Another one, fourth one, same, verify Rolle's theorem. For all these, verify Rolle's theorem. Tan x in interval 0 to pi. All are simple problems. You can take time also, need not be hurry. F of x equal to, what is this? See this problem. F of x equal to x 0 less than or equal to x less than or equal to 1, 2 minus x 1 less than or equal to x less than or equal to 2, x less than or equal to 2. And another one, see one problem, I need to tell one question fastly. Verify Rolle's theorem for function, you take this as something 1 minus x power 2 by 3, 1 minus x power 2 by 3 in the interval minus 1 to 1, for example. Okay, solution. F of x is what? F of x is, clearly this function is continuous everywhere, continuous and differentiable. Not, don't say, don't take differentiable. Is continuous everywhere in minus 1 to 1. It is defined uniquely, right? Continuous means. Coming to differentiability, if I calculate f dash x, what is this? Minus 2 by 3, x to the power of what? 2 by 3 minus 1, minus 1 by 3. That means minus 2 by 3 into x power 1 by 3 does not exist at x equal to 0, belongs to what interval? Open minus 1 to 1. Therefore, f of x is not derivable. F of x is not derivable in open minus 1 comma 1. Therefore, Rolle's theorem cannot be verified. Rolle's theorem cannot be verified. So for every problem, verification is not possible. This is one example where Rolle's theorem cannot be verified. I think for this problem also, I think this tan x, it is not verified. And coming to this, at x equal to 1, what is the left limit value? 1. What is the right limit value? 1. I think same, both are same. But coming to derivability, f dash x is 1 here and f dash x is what here? Minus 1. So differentiability fails here in the 5th question. Okay, you write clearly step by step. And let me give last one problem. Last problem, this is also assignment. Try this. It is given that the Rolle's theorem holds Rolle's theorem holds for the function. Rolle's theorem holds for the function f of x equal to x cube plus bx square plus cx. 1 less than or equal to x less than or equal to 2 at the point. Rolle's theorem holds at the point x equal to 4 by 3. X equal to 4 by 3. Find the values of a and b. Find the values of b and c. B and C. This is one more problem. Okay, these are the problems based on Rolle's theorem. In the next class, I will tell Lagrange's mean value theorem and Cauchy mean value theorem problems. Any doubts?